Hi students, in this lecture I am going to discuss dynamics of subtler motion. Let us see. So in the last class we have discussed whenever a particle follows subtler motion, its acceleration having two components. Its acceleration is having two components. We can see one is centripetal, other one is tangential. So this is now resultant. So acceleration having two components. If you multiply centripetal acceleration with mass, then that is net force towards the center, that is known as centripetal force. So writing centripetal force equal to mass into centripetal acceleration. So the net force acting on the particle towards the center is called centripetal force. And we have seen that this centripetal acceleration is responsible for changing direction of velocity. Changing direction of velocity. And because of a tangential acceleration, speed changes, means modulus of velocity changes. So here basically to be in circular motion, there must be centripetal force because that force is changing direction of motion. So without centripetal force, circular motion is not possible. So whenever any question given basing on circular motion, first we have to focus which force is providing or which forces are providing centripetal force. And next we can write here tangential force. Tangential force is equal to mass into tangential acceleration. Simply net force mass into acceleration, net force mass into acceleration. For example, this motion is confined to xy plane. Then we can write normal to xy plane net force 0, right? That means I can say along z direction, along z direction net force 0 because net force 0 means there is no acceleration, right? So if any question given, first we have to focus which force is providing centripetal force. Now let us understand by taking few simple problems. See first one. A two-wheeler taking a turning off radius r on a horizontal road with a constant speed v. Find the maximum value of v so that he can take turnings safely. So condition is given that road is horizontal. Speed is given constant. Speed constant means there is no tangential force, means no tangential acceleration. Radius are find the maximum value of v so that he can take turning safely. See how we are starting the problem. So given road is a horizontal, we are seeing from the top. Road is horizontal. Just observe how many forces acting on the two-wheeler. Okay, we can see mg. Mg is now into the board because we are seeing from the top, right? Or we can say road horizontal means mg vertically downwards, normal reaction is upwards. And these two are balanced. Normal reaction is balancing mg. because mg vertical downwards, normal reaction upwards. You can see in the plane of the road, there is only one force acting on the two-wheeler, that is frictional force. It is frictional force. And second condition, given speed is a constant. That means tangential acceleration is zero. That means no tangential force. Okay. Therefore, net force on the particle is nothing but centripetal force. So net force is nothing but centripetal force. Now, in the plane of the road, the only force acting is friction, and that friction must be towards the center. Must be towards the center. That means we can write frictional force. And I'm writing here F suffix S. The reason is that the two-wheeler taking turning without slipping. So no slipping between the tire and road. So friction is static. Okay. That's why I have taken here F suffix S. Therefore, I'm writing here centripetal force equal to mass into centripetal acceleration. Centripetal force, it is now static friction. That is equal to mass into V square by R. It is V square by R. Now see carefully. We have to find V maximum. V maximum how much? Right? Here mass is a constant. Radius of the circle is a constant. So now V depends only on static friction. And when static friction becomes maximum, V becomes maximum. And we have learned that in friction, maximum static friction is called limiting friction, right? Limiting friction, which is equal to mu into normal reaction. It is mu, or I can say mu s into normal reaction. Now in this problem, normal reaction equal to mg. Normal reaction is mg. Therefore, it is a mu s into mg. Now substitute here mu s into mg, that is equal to mv square by r. Now v value is maximum. So mass gets cancelled. So v maximum is equal to root of mu s gr. That means this maximum speed depends on one is coefficient of static friction, second one radius of the circuit, because g is a constant. So we have to first focus a free body diagram. Students, you have learned this in Newton's laws of motion, right? So first taking free body diagram, then we have to focus which force is providing centripetal force. So in this, friction is providing centripetal force. Reason is that there is no tangential force. So net force is now centripetal force, which is frictional force, right? Let us see next one. A two-wheeler is going on an overbridge of radius r. If the vehicle maintains a constant speed v, find how the normal force on it changes, right? So again, given here, maintains a constant speed. Speed constant means no tangential force. So net force is nothing but centripetal force. Okay. Let us see free body diagram. We have to find normal reaction. So first step, focus. How many forces are acting on the two-wheeler? So it is given an overbridge. You can say convex shape, right? Convex shape. Let us see now. Suppose at one instant, vehicle is now, vehicle is now somewhere here. This is vehicle. It is now going up the bridge. Suppose the line joining the vehicle and center of the bridge makes an angle theta. Okay. Now see free body diagram. Normal to contact, we have to take normal reaction. That is now N. Next, mg, it is always vertically downwards. Mg. So only two forces are acting, right? Normal reaction and mg. Okay. And you are having maybe frictional force which is along the tangent. It is along the tangent. Okay. But here condition is given that no tangential acceleration. Given no tangential acceleration means net force. Net force along the tangent is zero, right? Now we have to focus. What is the net force towards the center? Okay, because we are knowing that net force towards the center is called centripetal force. What is it? It is called centripetal force. So I'm taking here component of mg towards the center. That is now mg cos theta, right? I am writing here. It is mg cos theta, component of weight. So here for majority of the students, a doubt comes like which force we have to resolve. Is it normal reaction or mg? And how to know that? So we have learned that in Newton's laws of motion, which force we have to resolve. That is along the motion direction and normal to motion direction. Motion direction means it is direction of velocity. So in circular path, velocity is always along the tangent. So take forces along a tangent and normal to tangent. Normal to tangent means it is along the radius. If you see normal reaction is already along radius. So we should not resolve normal reaction. So we should resolve mg. We should resolve mg along the radius and along a tangent. Okay, along radius and along tangent. So it is now centripetal force. Centripetal force is equal to mass into centripetal acceleration. Now centripetal force, see carefully. It is mg cos theta, mg cos theta minus n. This is net force towards the center. I am repeating. This is net force towards the center. And this is equal to mass into centripetal acceleration, that is v square by r. Okay, so from this we can write normal reaction equal to mg cos theta, mg cos theta minus mv square by r. And it is given that speed is a constant, mass constant, r constant, so this is a constant. So as the vehicle moves up, as the vehicle moves up, theta decreases. When theta decreasing, cos theta increases. Okay. Therefore, normal reaction increases while vehicle is going up the bridge. I am repeating, theta decreasing, therefore cos theta increasing. So total value increasing. Therefore, normal reaction increases. Okay. Suppose question is asked like find frictional force at that instant. Find frictional force, frictional force at that instant. Okay. See what we can do. So we have condition that at equal to 0. So tangential acceleration is 0. Its meaning is tangential force equal to 0. We can see how many forces acting. I can take here for weight one component along the tangent, that is, this is mg cos and this is mg sine theta. And this force must be balanced by frictional force, right? That means frictional force is equal to mg sine theta. So if they ask like how frictional force changes while it is going up the bridge, how frictional force changes while going up the bridge, while going up, theta decreasing. Since theta decreasing, sine theta decreases. Therefore, frictional force decreases. So like this, we can expect any question basing on free body diagram. So this entire circular motion dynamics part based on free body diagram. If you are thorough with that, you will have very much means you can solve any question of your own. Okay. See next one. A block of mass m is placed on a rotating turntable. It is placed at a distance r from the center. If the block does not slip, find the frictional force on the block if the table rotates with a constant angular velocity. So it is a very simple question. Given block of mass m placed on rotating turntable, distance given r, distance given r from center. Block does not slip. Frictional force on the block. Condition is omega constant. So it is just a matter of a single step. Rotating turntable. A table is now rotating. Table is now rotating. At a distance r, we are placing an object. And you can see once again normal reaction upwards, mg downwards. These two are balanced. Now only force in the plane of the table is friction. So which has to provide centripetal force. So friction provides no slipping. So friction is static. So static friction, that is now centripetal force, which is equal to mass into centripetal acceleration. It is given constant angular velocity. So I'm writing in the place of AC, it is r omega square. So this is now static friction. Okay, m r omega square. So it is just a matter of single step because omega is given constant, no tangential force. Okay, right. See next one. A particle of mass m attached to one end of a string of length L. It is rolled in a vertical circle of radius L. Find the minimum speed of the minimum speed the particle can have at the highest point of the circle, right? String length is L, attaching a point mass m, asking minimum speed at the highest point of the circle. Okay. So again, we have to focus on free body diagram first of all. So he's asking at the highest point. At the highest point, first focus number of forces acting on the particle. This is now particle and this is now string. Center length equal to L. Okay. Right. So focus now free body diagram. So we are solving the question from ground frame. So weight mg vertically downwards. So weight mg vertically downwards. Tension by the string on the particle. We are knowing that tension is always a pulling force. Therefore, it pulls the particle down. So tension is down, means towards the center. So you can see net force on the particle is mg plus t. Okay. So I'm again writing here centripetal force equal to mass into centripetal acceleration. Centripetal force. It is now net force towards center. Net force towards center is mg plus t. Both are towards center. So I'm writing here mg plus t, centripetal force. That is equal to m into centripetal acceleration is v squared by r. Okay. R is given as L, right? Remember, this is not a force. M into AC, that is not a force. If you have any force, that is only on the left side. So here, how many forces acting on the particle means only two forces. We should not say three forces like mg tension centripetal force. Centripetal force is not a separate force. Okay. Resultant of these two is now centripetal force. Right. Now question is, what can be the minimum speed? From this equation, if you observe, mass constant, mg constant, mass constant, L is a constant. V depends on tension. If tension is a minimum, V becomes minimum, right? And we are knowing that tension can never become negative. Tension zero means string is loose. Okay. String is loose means circular motion is not possible. So tension can never become negative, either zero or positive. Therefore, its minimum value is zero. So when tension becomes zero, speed becomes minimum. Okay, because remaining are constants. Therefore, mg equal to mv square by r. R is now L. So mass gets cancelled. So v value root of gr. Then r is now L. Okay. So this is a minimum speed. So if you observe here, the only thing is taking free body diagram. So only two forces acting, both are towards the center. Therefore, centripetal force is mg plus t, mg constant that we cannot change. Therefore, if tension becomes a minimum and its minimum value is zero, then speed becomes minimum. So it is just a matter of free body diagram. So we should be strong at a free body diagram to do problems in circular motion, right? Let us focus on next problem. Find with what minimum speed a bucket having water should be rolled in a vertical circle so that water does not fall down even when the bucket is inverted at the top of its path. Even when the bucket is inverted at the top of its path. So this question is almost same as the previous question. Okay, let us see. Condition is water does not fall down. So it does not fall down means first focus free body diagram. Let us take now. This is a bucket and this is now inside. Okay, water. Okay, we are focusing now water. What we are focusing? We are focusing water. So system is water. Okay. So we have learned that in Newton's laws, while taking free body diagram, first we have to focus on which body we are writing forces. So we are writing forces on water. So number of forces acting. Suppose this is now center of the circle. Bucket follows now circular path like this. Circular motion. Circular motion like this. Now see how many forces acting. One is mg downwards, means towards center. Second, water has a contact with the sides of the bucket. So force by walls of bucket by the sides, it will be horizontal. By the sides of the bucket, force acting on water is horizontal. And by symmetry, those forces are cancelled. And if you see remaining one is bottom of the bucket. This bottom of the bucket exert a force on water downwards. That is a normal reaction. I am repeating. Bottom of the bucket exert a force on water downwards. That is towards center. That means on water net force is mg plus normal reaction. So this net force towards center is called centripetal force. So I'm writing here centripetal force equal to mass into centripetal acceleration. So we are writing all forces on left side. That is mg plus n. This is almost same as the previous one. mv squared by r. Again here, normal reaction. If water is having contact with the bottom of the bucket, n will be positive. If water is losing contact with the bottom of the bucket, n will be 0. Therefore, normal reaction can never become negative, either 0 or positive. So to have speed minimum, n should be minimum, and that minimum value is 0 because mg constant. So again, mg equal to mv square by r. Mass gets cancelled. So v equal to root of gr. So same as the previous problem, right? Like this, we can solve problems. So I hope you got clarity.